All right, folks, we're going to be starting in a few minutes. Hopefully you see the first slide. It says Chapter 8 Quiz, Tips and Questions. And I'm just going to specify the chat area / issues. If you're having, also if you're having computer issues, getting connected or something like that, you can let me know what the issue is in here. In the Google Doc. So the Google Doc will be our space to kind of type and talk to each other. And the live webinar will be where I present you a few slides. We're going to have like a 10-minute presentation, and then I will be able to pull up a Sketchpad and actually show you some problems or respond to problems that you have questions about. So we'll just wait another 2 minutes or so, wait for a few more people to get here, but hopefully you are viewing, and we're going to go live in about 3 minutes. 3 minutes, we'll start our presentation. Can you see the first slide? So indicate in the chat area, can you see the title slide? It says Chapter 8 Questions. And if you can see it, just let me know. We're going to be starting in about 2 minutes. Doesn't look like everybody's connected to the webinar. I see a lot of people on the Google Doc, but not everyone is connected to the slideshow. You're not going to be able to see me, but you should see my presentation. You should see the Chapter 8 quiz, tips, and questions. All right, so I see Gwyn, Sadie, Emily Tao, Noah, Robbie has joined us. Here's Victoria. Aye, Robbie. Yes, sir. By the way, do you know the pirate's favorite letter? Oh, we'll talk about that one later. Some other people are joining us. We have, thank you, Robbie. You can see the title slide. And below that, if you notice that I'm going to be answering questions in the questions area. So we're a little bit more organized this time. I apologize, those of you who tried to sign up for Google+. Thank you for those of you who told me. But Google+, apparently the school does not allow you to sign up for them using your Google accounts. So I'll find out about that, why that is, but we're not allowed to do it. So you can't use the live chat or the live Q&A features unless you have a Google+ account. So the Google Doc will help for our purposes. And just about 1 more minute, we'll see who else joins us. Hi, Kang. I see you're in that Google Doc now. And looks like Nate Stallone has made an appearance. Emily Hughes. Hello there. All right, thanks, Gwyn. You can see the title slide. Hola, Kang. ¿Cómo está usted? So we have a little Espanol here. That's good. Emily Tao has established Sky Blue. So no one takes Sky Blue under threat of Emily Tao, who called Sky Blue. And just about 30 seconds, we're going to get started. We're going to start on time. So the people who missed the beginning of it, I know some people might be coming late or getting back late. I'm going to send out the replay later. You won't be able to interact live, but you can at least watch the replay and get some information there. So any questions you had from your studying, let me just start by saying this, and then we will move along with the presentation. Any questions you have that you have discovered while studying for this quiz, you can go ahead and type them or write in the questions area. So the questions area is below the chat area on the Google Doc. If you scroll down, I should be the only one writing in black. You can all write in colors. So Kang, I see you're in like a bold font there, a black color. If you could just change that color, we will just let you be colors. I'll write in black so everybody knows when it's me talking. And if you have a question, like Robbie's typing in a question, you can just start typing those in the questions area, and then I will get to those right after the presentation. So I'm going to give you about 10 minutes of the presentation, and then I'll get right to your question. So if you type it in black, just change the color so I know it's a student question, and then we will get to that. Okay, so without further ado, let's get started. So this presentation here is Chapter 8 Quiz, tips and questions. I'm going to give you some information about what to look out for, and then I'm going to take your questions that you've uncovered while studying. So first thing, format. It's going to be 5 questions, 10 points each, and you're going to have to show some strategy for the quiz, as you usually do. You're going to be given 35 minutes, so you'll have a few minutes to come in, get settled, get your pencil sharpened, get your calculator ready, maybe do some last-minute studying or memorization, and then we'll get started about 5 minutes into class. So timing and strategy just means you want to do these problems the most efficient way possible. Yes, you want to get them right, but you don't want to use a crappy method that's going to take you an extra 5 or 10 minutes that gets wasted. So my advice is start out with ones you know how to do. And if you get stuck, you stumble, you can always go back to that problem. You could try to work through it at first, and then you can go back to it. So for example, my grad school final exam, it was 6 questions. I did not start with number 1. I actually started doing number 2, and I started it, and then I got stuck at part of it. So I moved on to number 3, and then I did that one. And then later on in the test, I went back to number 2. So you don't have to do these in order. Do what you know first and what you're comfortable with to make sure to get a little rhythm going. You want to get some questions right in the beginning. So format, watch your time. You want to work efficiently. There will be a matching section. Just like the last test, it'll be a little bit shorter, though. It's only 5 questions instead of, I think the last one was 7, something like that. But it might have been 6, but it was a few more. This is only 5 questions, and they're only 2 points each, so not as high stakes, but you still want to get them correct. You want to know your algebraic tools and your graph tools when you're getting into this. So, for example, actually there's a typo here. It should say ignore number 3 and number 5. Number 3 and number 5 on the study guide, and I'll talk about this if somebody asks a question about it. Those, actually, it's going to be numbers 3 and 4. Okay, so sorry about that. It's not 2 and 5. It's actually 3 and 4. 3 and 4 are items, general statements, general functions on that study guide that refer to things that you need those rules for. But I told you in class you don't need the rules from the textbook. So those are the rules that I'm referring to in section 8.3. They are not needed strictly. You can memorize them, you can learn them, but they're not strictly needed. So I'm going to say ignore numbers 3 and 4. And when I share these slides with you, I will share the slides with you. Someone might ask about that. I will edit that. Okay, so I will edit that and make sure you have the accurate slides there. But don't worry about number 3 and 4. So these tools, you got to be able to find your intercepts. X and Y intercepts, anyone should be able to find by setting, x equal to 0, y equal to 0. You got to know how to find your vertical asymptotes. You should be able to sketch things on a calculator if needed. And you should be able to use a table of values to find horizontal asymptotes. Also, you can find minimum and maximum using the calculator function. So just preemptively, I see Victoria typing a question about horizontal asymptotes. That's going to be using the table of values on your calculator. You're going to let x get really large or x get really small, and then you can find it that way. All right, so that's some tips for the matching section. Next up, we have some graph tips. And graph tips for rational functions. You do need to know how to graph. Sorry about that. Turn that cell phone off there. But there's 2 types. You can have hyperbolas, the straight up hyperbolas, which are that certain form of equation, a over x minus h plus k. Just memorize that parent function and then know how it shifts. So that's just a matter of those symbol type of rational functions. Then there are the general functions, which we know can be very messy and all over the place as far as what they look like. So my advice for the general functions, you got to be able to find those asymptotes. I see people asking about that. We will talk about it if you don't know, but you do have to know how to find asymptotes, and then you do have to be able to identify domain and range. You should be able to do that with any function for the rest of the year. Next up, read the directions. Algebraic tips, slide 1. Make sure you read directions in this quiz or test. Some people on the exit slip made equations out of things that are not equations, and you want to make sure you have, or you don't do anything that you're not asked to do. And if it asks you to simplify, multiply or divide, you don't need to set up an equation. That just means you want to take an expression, perhaps factor it, perhaps cancel common factors, and break it down into its simplest form. But you don't need to make an equation out of it. So keep track of whether this thing is an equation. If it says solve an equation, find the solutions, well then yes, you have to keep track of the left-hand side and the right-hand side, and your ultimate goal is to isolate a variable. Okay. Next up, algebraic tips number 2, complex fractions. So how to simplify complex fractions. This was on the exit slip, and a lot of people had trouble with it, but my advice is this first bullet: obtain a single fraction in the numerator and denominator. Capital N and D there are numerator and denominator, and you want to work neatly. So first, get a single fraction in the numerator and denominator. You might show your work like I do here. N, capital N, stands for the numerator, and just deal with the numerator. Literally write the letter N, and then write equals this, and then do some simplifying, and then equals this, do some more simplifying, equals this, until you have a single fraction. Then on a separate line of work, say denominator, say capital D, literally write down capital D, equals this, equals this, equals this, and then you get a single fraction. Once you have the capital N and capital D, the numerator and denominator, you can write them horizontally in a division problem, which we know means you can do N, the numerator, times the reciprocal, or 1 over the denominator, which is another way to write the reciprocal. So you do division is just the same as multiplying by the reciprocal. Double check your work. Very easy to make little mistakes when you're simplifying complex fractions, so just double check your work. All right, algebraic tips number 3, solve rational equations. Use method 2. Okay, this was that homework with 6 problems. I hope you practice some of them. Don't go in cold. But my advice is use method 2. It's the best method. Do you have to use method 2? Is it wrong if you don't use method 2? No. Okay, it's not wrong. But method 2 is the best and the most efficient way to get to the right answer. And I like to teach you the best way to do the problem after you've had a chance to explore different methods. So using method 2, you're going to multiply both sides by the LCD. And once you do that, the LCD of all fractions in the problem, your next line will immediately have no denominators. Okay, so that's a good thing about method 2. Once you factor everything, you find that LCD, the least common denominator. Once you multiply by that, you no longer have any fractions. Okay, they will all be divided out, and you'll just have regular expressions, not fractions. You might be asked to solve a quadratic. If it's a degree greater than 2, if it's a cubic or a 4th degree, please use the calculator. Don't try to factor a 4th degree polynomial unless you notice like a real simple form. Go to the calculator to help you out on that. Okay, and then start with the rational roots and depress the equation if needed. Algebraic tips number 4. Don't forget about TPS 8.4 to 8.5. So I just wanted to bring this up because we haven't looked at those most recently since we've been focused on graphing, but they are part of Chapter 8. And these are just simplifying problems that involve factoring, multiplying, dividing, and dividing out common factors. So exponent to the -1, if you're a little rusty on that, that just means flip the fraction or make it its reciprocal. But you should be able to factor all of those and multiply and simplify there. Next up, let's see where we are here. That's a graphing example. I'll do that if we have some time or people don't have, or we run out of questions. I'm going to do an example of graphing that people might like to see. And for right now, I'm just going to say thanks for watching. Thanks for listening to that short presentation about the quiz. And now I'm going to turn it over to your questions and talk about those. I might go in order. I might go a little bit out of order. But I'm going to screen share you with a different item now. So I will post this. Let's see. Let me share those slides with you. But first, I'm going to screen share something different here. So, oh my goodness, hello. You have found me. I'm in the dungeon of my basement. And I'm going to put on the Sketchpad. Okay, so sorry if that shocked you, but here is the Sketchpad, which I have downloaded recently. It's an app I downloaded today, and it allows me to write on stuff. So I can post a problem in there, and I can draw on it live. So let's see what kind of, oh, you know what, let me share this, the slides with you before I forget. So period 3, period 5. Now you all have that PowerPoint. It's not a PowerPoint, it's a Google Slides thing. I'm trying to learn how to use these Google apps, but I just shared that with you if you're curious. So let's get to your doc. I see a bunch of people have posted questions. No, not many people in the chat. Oh, thank you. I see new people have joined us. Hi, Juliana. And Beata is back, even though she was ruthlessly critiqued last time for her font usage. So thank you for coming back, Beata. I'm sorry for that abuse last time. And Jimmy is here. Hi, Jimmy. Looks like we can get started. So let's go to some questions. Robbie says, how do you do exit slip number 1? Well, let me pull that up here. Exit slip number 1. I'm going to paste that into the Sketchpad, and we'll look at that. Exit slip number 1. I might be brief in the explanation, but if you need more detail, then you can definitely follow up on that. Just follow up right below the question that you asked. But Robbie asked for exit slip number 1, and here it is, Robbie. I think this is the problem you're talking about. I'll make it a little larger, and I'm going to draw on it here. So this is a complex fraction. So what you want to do, if you're following the method I showed on the slideshow, you want to first get a single fraction in the numerator and the denominator. So this thing is the numerator, numerator, and denominator. You want to work to get each of those as a single fraction. So in the numerator, I would multiply this first fraction by 3 over 3, and that'll get me a single common denominator of 3x if I multiply the second fraction by x over x. So that's what I would do first in the numerator. If you simplify that numerator, you'll get 3 minus 3x. I'm sorry, not 3x. No board points. Those of you going for board points here. Let me see if I can learn how to use these paint settings, so be patient. But it'll be 3 minus x squared all over 3x. So that's how you would do the numerator. And then the denominator, you would multiply. So you have two fractions here, x minus 1 over 4 and 1 over 3. And we want a common denominator of 12. So I would do 3 over 3 for that first fraction. And the second fraction, I would do 4 over 4. Okay, so you know what, hold on, just give me 1 second. Going a little slow here because I don't have my mouse plugged in. If I can get my mouse plugged in, I might be able to draw a little bit faster. Let's see if I can get that plugged in. Okay, we're still working out the kinks. By the third webinar, we will be moving along quite smoothly. So 4 over 4, and then you would get a common denominator there of 12, and you'd have 3x minus 3, and then plus 4, all over the common denominator of 12. Once you have the two fractions there, one in the numerator, one in the denominator, you can simplify them if possible, and then you're just going to, instead of dividing, you're going to multiply by the reciprocal. So you take that first fraction, 3 minus x squared over 3x, and you multiply by the reciprocal, which would be 12 over 3x plus 1. Okay, so that's what you'd have there, and then you can simplify that out. So, Robbie, I hope that answers your question for exit slip number 1. Let's see what other questions we have. So I'm just going to write in black here. Answered in the webinar. Victoria had a question. How do you find horizontal asymptotes? And for that, I'm going to type a little bit in the Google Doc, but I can do a specific example later if you'd like. But you want to check the table for very large, very small x values. Okay, we can look at a specific example. Basically, set x equal to 1, 10, 100, 1,000, 10,000, and then check what y is approaching. It's going to be clear. Okay, the calculator is going to make it clear if a horizontal asymptote exists. So not every graph has a horizontal asymptote, but if it does, then if you plug in very large x's, it's going to be very clear what y is approaching. You might, for example, get things like 3.01. and then 3.001, and then 3.0001, and it might even say 3. And so that number that's getting closer and closer and closer to would be 3, so then you would say y equals 3 is a horizontal asymptote. Okay. And I think I'm going to talk more about asymptotes because we have a few more questions on those. So Emily Tao asks, how do you find vertical asymptotes? I'm also having trouble with domain and range. Okay, some other people are going to ask about that too. But let's take the first question first. Vertical asymptotes are, I put in the presentation under the algebraic tools. I think it was the slide of the matching section, but you want to check where the denominator equals 0. Okay, if the denominator equals 0, let D be denominator, D equals denominator. If the denominator equals 0, then the function is undefined at that value. Okay, and if it's undefined at that value, it can never exist at that value. So if you have a rational function like with, if the denominator equals, let's just make it something like x squared minus 9, then you solve for when that would be 0. There would be vertical asymptotes. Vertical asymptotes at, well, you can't have plus 3 or negative 3. X equals 3, and x equals negative 3. So with the vertical asymptotes, those are going to be x equals, going back to Victoria's question, y equals is for horizontal asymptotes. So don't mix those up. If you mess up the x equals, the y equals, the asymptote will be wrong. Okay. Also, trouble with domain and range. We'll see if we can get to it. Maybe you have a specific example in mind, Emily, but domain is all possible x values. Most of the time, we just list what x cannot be. For example, if x can't equal 2 or x can't equal 3. And the range is all possible y values, or all the y values that get hit. Sometimes it can be all real numbers. It might be what a y cannot be. This varies more and is usually more challenging. Not always, but usually range is a little trickier to figure out. But start with those definitions, and maybe we'll look at a specific example a little bit later. Let me clear what I have here. I'm just going to clear that sketch pad in case someone has a specific one. Okay, another one on horizontal asymptotes. Gwyn says, I'm having trouble getting to the table to find horizontal asymptotes on the calculator. Can I do an example using the calculator? I get to a screen with words instead of a table. Okay, so first, let me write what to do, and then I can show an example. But first, use table set to make the independent variable set to ask. And second, you go to the table. You type in large x values, x equals 1, and then you increase them 10, 100, 1,000, 10,000. Okay, so you know what? Let me pull that up for a moment. Since Gwyn, you took the time to ask, I will like to make this beneficial, and I'll show you how to do that. So let's screen share for the moment. Give me a moment here. Let's find that calculator. So you're going to see me again. Don't be shocked. Oh my goodness. Here I am in the dungeon. Okay, so what do we want here? We want the TI-84. Okay, so Gwyn wants to see an example of a rational function. I think anyone would benefit from this. Let's say we had x squared plus 2 in the numerator, and divided by, let's spice it up, x squared minus 9, and times x squared plus 9. This is kind of mirroring an example we had in class, not exactly the same. But notice the double sets of parentheses I used. Whatever's in the denominator must be around parentheses. It must have its own set of parentheses. So the denominator, you must encase the entire thing in parentheses, but the calculator is too dumb to figure that out. Okay, remember, these machines are very stupid. Unless you tell them exactly what to do, they will not know what to do. So let's say that was our function, Gwyn. If you wanted to find these horizontal asymptotes, I don't know if it has any. Let me just graph it and see if anything shows up. Okay, we got some weird stuff going on there. It's a little unclear exactly what's going on in this function. So let's go to, let me just zoom out once, see what happens. See if we can see anything else. And then we'll go to the table and talk about horizontal asymptotes. But, okay, that doesn't look like it helped either. Let's change the window. Let's just go from 15. I want negative. Let's go negative 15 to 15. And let's try that y. Okay, I'm just making sure I typed that in right. Let's try the old zoom fit. We're not seeing anything too clearly, so you just got to play around with different zooms until you see something. Okay, here we go. We got a little something here. Hey, the zoom fit helped us out. So anyway, we suspect there's a horizontal asymptote going somewhere through the middle there. But if I want to find out what it is, I'm going to go to the table. Or actually, first I'm going to go to table set. So off of Gwen's question, I'm going to set the independent variable to ask. There's ask. And then I'm going to go to the table. I'm going to type in larger values of x. Start with 1, 10. We're looking for what it's getting closer to. 100, 1,000. And now it's pretty clear that this is getting closer and closer to 0. So that would mean, since this is 1 times 10 to the negative 4th, 1 times 10 to the negative 6th, negative 8th, etc. So this would imply that the horizontal asymptote is at y equals 0. Okay, so Gwen, I hope that answers your question. And let me go back to the Google Doc, see what other questions I have. So I'm going to say answered webinar. Oh my gosh, Victoria has an important question. We did not finish the 8.3 conclusion notes. Will you be giving us that? No. Well, not for the quiz at least. Those are the rules. Okay, 8.3 conclusion notes are the rules found in 8.3 of the textbook. They are not needed to be able to answer the problems on tomorrow's quiz. I said if people want to memorize some extra rules, they can do that. You don't need to know them for tomorrow's quiz. We will be looking at them on Tuesday and Wednesday, and we're going to be looking at some programming, but they're not required for the quiz tomorrow. But you can do everything without those rules tomorrow. Okay, you can use the calculator, you can use your algebraic tools to answer those. Okay, okay, some more questions. Let's go to, oh, Gwen, thank you for replying. She said she wasn't clicking second table after she changed the independent variable. Got it. Okay, just getting to the table. Will there be a question in the quiz where we can only use method 3? Also, will there be a question where you tell us to use, okay, no. You can use any method you like for any rational equation. Okay, any of the 3 methods will work. I recommend method 2 because it gets rid of fractions the earliest and the most efficiently. Let's write that down. Here's fractions. I recommend method 2, Juliana, but you can use any method at any time. Ooh, is there an answer key to the study guide with the matching things? Thank you, Jimmy. There were supposed to be. I apologize for not having that ready for you. So why don't I give that right now? Let me pull up the study guide. And let's screen share that, and I will give the answers to those. You've caught me again. Let's see, that would be this one. Sorry, I'm sitting so close to the computer. Not good for your posture. And where am I? Not that. I want to find the study guide. Oh, okay. Oh, this is it. Okay. So on the back. Yeah, again, Jimmy, I said 3 and 4 are void. or I'm not going to give you a question quite like that where you need to analyze degree, because those require the rules on section 8.3, which we did not examine for this quiz. And Victoria asked, do we need to know them? And I said no. So 3 and 4, I'm just going to say you can kind of cancel those out, but you don't need to know 3 and 4. Let's look at 1 and 2, the answers. Number 1 is going to be G. Number 2 is going to be H. So 1 is G, 2 is H, and there is no match for number 5. So 1 is G, 2 is H, and there's no match for number 5. Oh my gosh. Okay, yes, let me answer that. So let me just write these answers down. Answers 1 equals G, 2 equals H, and 5 equals no match. Okay, I will discuss. Sorry, I'm just getting answers quickly. I'm going to explain. It's okay. All right, so let's look at those. Zooming in on, so how do you figure this out? First, you want to see what kind of vertical asymptotes you're looking at, which is where the denominator is 0. So just looking at question 1, 2x minus 1 is going to be equal 0 when there is a vertical it's going to have a vertical asymptote at 1/2. I'm sorry, did I say 1 is G? That is not correct. No wonder you guys are confused. Let me find my answers here. Yeah, 1 is not G. Sorry about that. Because 1 only has one vertical asymptote, and the vertical asymptote is at 1/2. If you solve 2x minus 1 equals 0, comes out to 1/2. I don't know where I got G from. So the only candidate for number 1 is F. So looking at this, it looks like F would be our guess for number 1. To verify, you would want to see if it has a horizontal asymptote that's not 0 when you graph it on the calculator. So see how this horizontal asymptote doesn't look like 0. It doesn't look like high. It looks like maybe around 1-ish, maybe around 2-ish, but it definitely has one vertical asymptote. So the only candidate for letter 1 is F, not G. Sorry about that. And to double check that, let's pull up our calculator again. And you can plug that in. So here's our calculator. And let's plug in second quit. Sorry about that. Y equals, clear that up. And let's plug in number 1. 3x plus 1 over 2x minus 1. So in parentheses, I put 3x plus 1 divided by 2x minus 1. Okay, there's one way to figure it out. And let's graph that. And then we want to look for horizontal asymptotes. So I'm just going to zoom standard to start. Looks pretty much like F. So I'm thinking F matches this picture. This would be sufficient if those were the only choices to declare it to be F. Okay, tomorrow on the quiz, no match is not an option. It's going to be one of the choices that's given. So this only looks like F. You can tell from the calculator. For number 2, why is it H? Well, if you solve for those vertical asymptotes, you're going to get the square root. So if you do 4x to the 4th minus 9, you split that up. It's two perfect. It's a difference of squares. So it'll be 2x plus 3, 2x squared plus 3 and 2x squared minus 3. And you end up having the square root of 3 over 2 plus or minus the square root of 3 over 2 is your vertical asymptotes. So we actually have 2 candidates for number 2. It looks like it could be G and it could be H. If you look at the table feature Or if you graph it, you'll notice the horizontal asymptote for number 2 is going to be 0. So therefore, it's going to have to be H. And then 5 has no match because they all have a horizontal asymptote. So I'm going to say explanation in the webinar. It's on the audio. If you have follow-up questions, let me know. Let's go to Jimmy's next question. Okay, sorry about that. I got a little confused there. Domain. Black. The domain always X does not equal the vertical asymptotes. In general, not necessarily, but for rational functions, yes. Okay. So for problems in this quiz, that's going to be the easiest way to write domain. The reason I say in general, not necessarily, because if you don't have a rational function, if you have a quadratic or a cubic, then you may not write the domain that way. If you have a absolute value function, you might write the domain x greater than 0. But for all problems in this section or this quiz, yes, that is how you should approach domain. But what it can't be. Okay, but in general, you want to think of, you can always think of what the domain can't be, but the answer may not always be x does not equal. We only use that because if it's 1 or 2 or 3 values that x can't be, it's just quicker to write it that way. But if it's a set of like a ton of values, like x is always greater than 0, then we would write the domain like x greater than 0. So that's just a comment, but for this quiz, Jimmy, that is how you should do it. Okay. I'm not sure about this question in blue. Beata, can you just rephrase exactly what you mean there? I'm confident how to find the range. That doesn't really sound like a question. So maybe you can rephrase that. But I don't understand the matching. And number 2 on the TPS, Anna. Okay, so let me give some more hints for matching. So tips for matching. Look at the asymptotes. Okay, vertical asymptotes for the denominator equals 0. About that earlier. So check where that is. Look at the horizontal asymptotes on your table. You can even sketch from your calculator. If you do those 3 things, look at the asymptotes, check the horizontal asymptotes, vertical asymptotes. You may not even need to check in your calculator, but then if you sketch in your calculator, it should become obvious as to what the correct match would be. So those are basically the things you want to do, Anna. Just use your algebraic tools to check on those. Also, if you know the parent function, y equals 1 over x, you can see something looks like that. So you might be able to tell that it's just that function, but shifted x units over, y units, or 3 units over and 2 units up. But basically, that's how you would do the matching. If you know how to find asymptotes, if you know how to do the graph on the calculator. The calculator, I would say, is a last resort. Let's make this last resort because it takes time to sketch it. Yeah, you can use that to match it up. First, try to see if you can narrow down the choices without doing that. All right, some more questions coming in. All right, Beata's confused about how to find the range. That is almost a question. It's still more of a comment, but I think we can discuss that a little bit. Anna's your question. Anna's technically wasn't a question either, but I can still answer a comment. Let's talk about range. So you want to see where what y values the function passes through or touches. So what y, and the way I phrase it in class is what y values get hit and which don't get hit, meaning they don't get touched by the function. So if you have a horizontal asymptote, then that y value may or may not be touched. So, but a horizontal asymptote, you have to examine, is it an asymptote for the whole function, or is it just one branch that's not going to be touched? Horizontal asymptotes, that's one place to look for values that y can't be. So you might find something that y can't be when you look at the horizontal asymptote. Another thing is look for gaps. In number 2 on the investigation, there was a big gap between the top piece of the curve and the bottom piece of the curve. So look for gaps between branches. I'll say number 2 on investigation 8.6. It's a good place to look there. And if you do find gaps and you want to see, well, what's the space between, like what's going on there, then you can use the calculator function. Find min and max. And then you'll know what the gaps are. Okay, but if there's no gaps, your range is really going to be y does not equal this, it does not equal that. If there are gaps, you will have to use that min and maximum. But if there's no gaps, use format y does not equal. Let me see if I can find that symbol. Doesn't look like they have it. Equal does not equal. There we go. Y does not equal a number. That's the format I would use. Okay, that would be a good something to get you started on range. But if you have more questions, you can let me know. Okay, let's see who else. Oh, Sam and Jess joined us as well as Daniel. So a little shout out to those people who joined us a little later. Thank you. Okay, Victoria, good question. Will there be questions on the quiz with no horizontal asymptote? So I don't like answer that directly because I'm not going to give it away, but there could be. There could be. Probably not. The reason is the types of rational functions that don't have a horizontal asymptote are typically types that have holes in them. We didn't talk a lot about holes or discontinuities of that form, except for that one whole homework question. So maybe I wouldn't put that as a regular question, but maybe extra credit. Keep an eye out for that. We'll look at it more after the quiz too, though, because we do all need to know that. But likely there will be some type of horizontal asymptote. Okay, let's go to Anna for the study guide. My presentation on this. How do you figure out number 3 on the matching? You don't need to know that type for the quiz. The best way to do that one is to know the rules of degree. And there's a rule in the book on page, I forget what page it is, but section 8.3, where if the degree of the denominator is greater than the degree of the numerator, you would use rules to tell that there has to be a horizontal asymptote at x equals 0. You use rules from section 8.3. And we almost finished discovering those rules, but we didn't quite get there. So you don't need to know that type for the quiz. You don't need to know 3 or number 4. Those require the rules. We will look at those on Tuesday after the quiz, but you don't need to know them for tomorrow. Okay, another question from Jimmy. Finishing up a question there. Okay, we have some infighting. Shout out to the new squad. Yes. Aye. Hopefully, Robbie, you're still with us. Give us an aye. Don't know what I mean by gaps. All right, Jimmy, let's look at a picture of that. If you pull up, I'm going to go back to my calculator. Oh, we have my calculator. So we're screen sharing my calculator right now. And you can have the Google Doc open to the side. But let's see what I mean by gaps. So if I type in a function, let's look at number 8.3 on the investigation. Number 2. Okay, that function was parentheses. This is number 2 on 8.3 investigation. It was 3x squared plus 4x, and Jimmy, you might even have an answer sketched, plus 1, close parenthesis, divided by x plus 4. And I gave you a suggested window. I would not give you that on the quiz. You have to figure it out for yourself. But, oh, syntax error. What did I type wrong? Okay, I need another parenthesis. Insert there. Yeah, always forget your don't forget your parentheses. Gotta have them in the numerator and the denominator. But this graph has 2 branches, and you're gonna need a little bit of a bigger window to see it. So I'm gonna drop my y's down to -80 and go up to 40. And what I mean by gaps is that between this value here and this value up here, between this value near the x-axis and this value by this branch, there's no points. There's no values on this graph. There's nothing that's hit in this space. So this is a gap in the range. In order to find out, well, what's not hit here exactly, you'd have to know what the number is at the top of this branch. And to know what the number is at the top of the branch, you'd find a maximum. And you'd also have to know what the lowest number is on this branch. To find the lowest number, you would find the minimum. So you use second calc, and you would use the minimum or maximum function. If I wanted to do a minimum, I'll just do a left-right sandwich for you. Left, then I go right, to the right bound, and then I press enter twice. So my minimum is about -0.1 for the y. And then I would find my minimum for the x. You're slightly off on the rounding there. It's not going to be a major issue, but use the calculator when there's gaps. So I'm going to put that as answered in webinar. Whew. Okay, and a good question. How do you know if it has no vertical or horizontal asymptotes? It has no vertical asymptotes. The denominator cannot be 0. If the denominator cannot be 0, meaning denominator is always a number, then there can't be a vertical asymptote. It's a non-zero number. So if the denominator is like something like this, x squared plus 4, if that was the denominator, d equals x squared plus 4, then you would have no vertical asymptotes because it's impossible for this to be 0, or sorry, this denominator to be 0, because x squared is a positive number, and then you're adding a positive number to it, so there would be no, there would be nothing where you could have a 0 in the denominator. This is where Brandon Dennis, if you were here, might say, well, what about I? And we're only looking for imaginary, we're only looking for real numbers when considering asymptotes. Not worried about imaginary numbers. So we don't care if like 2i or -2i make that 0. So vertical asymptotes, we're only looking for real numbers. Right. Let's see. Moving along. And Jimmy, I hope that helped. If that didn't help and you have an additional question, let me know. Okay, so we have another question. So there won't be anything about P of X or Q of X in the matching. That is correct. Let me just look at the quiz itself and double check. Yeah, there's nothing about P of X and Q of X. It will be like number 1 and number 2, or a statement about asymptotes, domain, range. For example, graph has no vertical, or it has 2 vertical asymptotes. You have to match it. Or example, horizontal asymptote, y equals n, where n is greater than 2. Okay, so those would be examples of questions that I could ask. So it'll be either numbers like 1 and 2 where I give you an equation, or it'll be statements about asymptotes, domain, or range. And you have to kind of decode and match it up based on that. Okay, so that is the next question there. Apparently Brandon is with us. I don't know if that's true. We're getting some people are getting tired here. Brandon is with us in the form of the Force. Know my story. No, you don't have it right. You don't have it right here. I was typing this. You're making me laugh, but it's hashtag know my story. Forget what that was. That was what did I write? Oh yeah. It was really supposed to be no mystery, but I like know my story better. Yeah, you got to know your story. People, they should know you. They should know your story. And hopefully your story is that you're going to crush this quiz tomorrow because you've studied and you're ready. But I'm going to say we are at 9:04. I said I would go till 9:15. So I'll give you a couple minutes. If you have any additional questions, I'll try to answer those. Let's go back here. So this is the quiz. Here it is. You can kind of read it backwards. There's going to be 45 copies that I have to make. And here's the answer sheet. That's not going to help you too much. But let's go to the doc and see if you have any more questions. If not, we'll wrap it up. But I will give a last call to questions. These are some Christmas presents I have to wrap. And this is the layer where I do my math problems. Okay, that's okay, interesting. Okay, we have a very large question. Can I please give this? Okay, not if you write that big. Whoever's asking this, I can't even process this. Yeah, the newest trend. Let's make that trend on Twitter. I don't have a Twitter, but you guys can play around with that. Okay, I got it. Sample question. Sure. Here's a sample question. Ready? Those of you on the webinar, those of you sticking with us to the end, here's a bonus. I know Jimmy, she does that. She likes to do that. It's hard to prevent. But, well, what can you do? So here's a bonus. Those of you who stayed on the webinar to the end, sample question. Graph. This. Actually, you already kind of saw it. Let's go to the presentation. Oh no. Sorry, one moment. It was minimized. Bonus. Sample question. This one. Graph that. 4x cubed minus 2x over 4x to the fourth minus 9. So that would be a sample. Actually, you know what? Sorry, I need to modify that one because that has a little discontinuity issue. Let me put that in my sketch pad. We'll do it together. So where's the sketch pad? That's not the sample. That's not the sample. Don't graph that one. That one's got a weird discontinuity. Sketchpad. Sketchpad. There we are. Sketchpad. Okay, this is the last thing I'm going to do. And then I will, if there's questions, I'll answer them off the webinar and paste it. But let's paste that in. Okay. So maybe this is your bonus sample. Those of you who stick on to the end, we're going to graph a question like this. Let's find it. Where did it go? Sorry, stand by. The graph is coming. Long enough, you deserve to see a sample question. Okay. Can you see it? Nope. That's not it yet. Sorry. Technology fails here all across the board. Okay, here it is. All right, this is the sample. Graph this. This is a sample graph question. I mean, there's other types of questions. You can study the other stuff or read the presentation. But say I asked you to graph this. One thing you might want to notice first is what are the asymptotes? So if I asked you to graph this, you would want to have vertical and horizontal asymptotes figured out. So this is going to be, forgive me, this is going to be very messy with the mouse, but no board point for this being tilted. Vertical asymptotes, when is this denominator equal to 0? Well, x squared plus 8 can never be 0, at least not for a real number. But x squared minus 16 can be 0. That's going to be 0 when x equals plus or minus 4. So x equals plus or minus 4 are going to be my vertical asymptotes. So I'd make a dotted line. X equals negative 4. Forgive me for the messiness. And dotted line here, where x equals positive 4. That'd be my first step for this. Secondly, I would graph it on the calculator to get a better picture of what's going on. And then I would get my horizontal and vertical asymptotes. Or we have the vertical. I would get my horizontal asymptotes. So I'm going to cheat here and just type this into Desmos on the side to go quickly, but if you can type this in your graphing calculator, that's going to be y equals x squared plus x squared by 16 squared. Okay. So what I'm seeing from my calculator and what I did on the Desmos just now is that the shapes of the curve are like this. Boom. That was one branch. And then we have boom, another branch. And then we have a third branch over here. And I would check on my calculator table function. You'll find out that the horizontal asymptote is indeed y equals 0, as it looks like it. But you can check table features to see what the x's are, 1, 2, 3, 4. No, sorry, 1, 10, 100, 1,000. And you should know what this y-intercept is. I do ask you to graph x and y-intercepts if needed. So if you set x equal to 0 in this equation, and then calculate that, you will get a decimal. It'll be about negative 0.06. So that'll be 0, negative 0.063. Turns out to be my y-intercept. And there is no x-intercept. So that's the deal with that. And that would be the graph. Domain and range. Well, domain, x cannot be 4 or negative 4. Range, y cannot be 0. Everything else is fair game. I'm sorry, this range is a little bit trickier. Y does not equal 0. That's true, but we actually have a tiny gap. Just realized that. So part of the range is that y can be greater than 0. Okay, that's all this part up here. Those of you sticking on to the end, this is a good thing to see. So this section here tells us that y can be anything greater than 0. But this portion here tells us that y is never going to get closer to the x-axis in the negative direction, then this y-intercept. Okay, that maximum is as close as it's going to get. So, or y can be less than or equal to negative 0.063 or 0.063. All right, so Jimmy asked, where are the gaps? This is an example of a very tiny gap. I kind of just made up this problem on the fly, so it may not, it's probably not going to come out that messy tomorrow, but that would be an example of a tiny gap in solving that problem. Okay, so let's wrap up this webinar. Thank you so much, those of you who came. And okay, well, let's be nice. Hashtag Beata's not a hacker. That's not true. What is a grid graphing calculator I can buy at the mall? Well, you don't have to buy it at the mall. You'll find it on Amazon and other places, but TI 84 Plus is a good one. Also the TI 89 Titanium is good if you want to go to AP Calculus. And what is, okay, how does one do math? My computer crashed. What's the hardest question on the test? It depends. If you're bad at graphing, it's the graphing. I'll answer the rest of these off the air. Okay, I will answer the rest of these off the air, but we got to close this webinar because it's over time. Thank you so much for watching. Hope it was helpful, and I'll see you tomorrow.